Hi, recently I came across something very strange with linear regression and so as well as the coefficient of determination. So I actually have data which I generated, which is very clearly having a negative correlation. As you can see here, the data as GDP increases, the educational level drops. Okay, so this is just some random data that I have, but you can see that the trend line is clearly negative. And in fact, if you add the trend line, it will generate a very good R-square value of 0.996, and the coefficient for X is actually minus 0.049. However, if I actually try to use my Excel to actually generate the regression analysis, I find a very strange result coming out from here. So if I go to data analysis and I say I want regression, and then I select the Y input range, which is basically the educational level, and the X input range, which is the GDP, and I select I want the labels in there, and I want it to generate the residuals as well as the fit. As I click OK, I get it out as a separate sheet. Let's just space it out a little so you can see very clearly now. R square is still a very good value of 0.996 as before, as shown on the graph earlier. You can see the fit plot is, as we have expected, is almost a straight line. And the coefficient of correlation coefficient, I have a very strange label here. Instead of this saying small r or correlation coefficient, it just says multiple r and it's 0.997. It's not negative, which I expected it to be, because actually this graph is clearly having a very close or strong negative linear correlation. So what's going on here? So I'm not convinced that this analysis is correct. So I'm going to use the Excel other feature, which is the correlation analysis. So I select correlation from the data analysis tab. I put in the input range, which in this case is just this two, and labels in the first row, and I click OK. So it generates. So voila, obviously there is a negative correlation here. So why did it actually produce a positive value for multiple R? And what is multiple R? Do we see actually the same values for SPSS? So I'm going to try this with SPSS with the same values, and I'm going to show you what we get in SPSS instead. So I've opened up SPSS. Took a while, but it's finally done. Then I'm going to add in the same file with my sources. I'm going to use a bar file. Let's point it to my file, which is basically a CSV file. SBS does tend to read a bit faster for CSV instead of Excel spreadsheets. So I normally use a CSV file. I just copy the data across. Now, so I'm going to basically connect a type node to this. And the serial number is none, and the target is actually the educational level. So apply, and if I actually use the regression node, put it in the regression node, and I run it. So the target nugget is here. Let's take a look at what the nugget has. Okay, so summary. Notice that the correlation coefficient is a negative coefficient for B for the GDP. And if we look at the advanced values, especially the ANOVA table, the model summary, If R square is 0.996, which is the value very good, close to R1. But the R here is also not negative. It's also positive value 0.998. It's the same value as multiple R in Excel. So what's going on? I close this. I actually use the analysis node to just have a double check of that value, and I run the analysis node. Find that again the linear correlation, instead of being a negative 0.998, is actually a positive 0.998, the same value as the multiple R in the Excel spreadsheet. So this value seems to be consistent in terms of the value, but the sign seems to be wrong. And in fact, if you read the documentation for this analysis node, this value linear correlation is supposed to give you values from -1 all the way to +1 for a very strong linear correlations. But as you can see here, the expected negative value doesn't appear. So I'm going to actually show you why I think this is the case for these two values and what's the meaning of that multiple R. So if we actually go to Wikipedia, which is like an online encyclopedia, you see that there's a definition for coefficient of determination, or R square, as that we are familiar with in the Wikipedia, and it just tells us that R square is normally denoted with a capital R with a square, and it's used as a way of for determining the model fit. So there are several definitions. So in one class for simple linear regression, this is actually the square of the correlation coefficient, the small r, which has a positive value of 1 if it's very good and negative value of 1 if it's not so good. But if it's a multiple correlation, it's a multiple linear regression, then R square is actually a square of another coefficient which we have not come across so far in our lessons, and it's actually a similar correlation coefficient, but it is called the coefficient of multiple correlation instead of just the coefficient of correlation. So what is this value range? Okay, the coefficient of determination is between 0 and 1. Correlation coefficient, which we already familiar with, is between -1 and +1. What is this coefficient of multiple correlation? So if I click this, it tells you that if it's a multiple correlation, then the meaning of a negative correlation doesn't have much, because you can't really determine the slope in a multi-dimensional linear graph, unlike a 2D graph. So the value of the multiple correlation is actually between 0 and 1. So finally we realized that, hey, actually for Excel spreadsheet, which actually supports multiple linear correlation, the value that it prints out as R or multiple R is actually this value. It's a value that's between 0 and 1, where 0 is very weak or non-existent and 1 is a very strong correlation. So 1 highest indicates a better predictability of the dependent variable. And it seems that similar calculations actually calculated by SPSS. So what it puts in as the R value and also the linear correlation value is actually the same. It's the multiple correlation coefficient instead of the correlation coefficient for simple linear regression. So I think this value is actually not the simple linear correlation coefficient, but actually the multiple R's is actually the correlation coefficient of multiple correlation. So that basically explains our mystery. Thank you.